Okay, we are in section 7.6, part D, I believe. If you have your notes, we're on page 7 of the notes. Okay, so we're going to talk about exponential functions. Exponential functions, they're functions that zoom up or can zoom down. We see some exponential functions, some examples here. This is one that is positive. It's y equals 2x, and it's going up. It'll get 2 times as high as, we raise the x value 2 times as high as the past x value on this one. This one goes in the negative direction because it's got a negative out in front. Over here, this is an exponential function, but it's a decreasing one. Both these, this one is an increasing exponential function. This is one that gets lower and lower, but it will never go below 0. This one over here on this side never goes below 0. Okay? Key concept today, a couple that we're going to have, is the domain. You may want to freeze the screen if you're watching at home, the domain and the range. The domain is the set of x values. It's the values you can put in for x. What numbers can I put into the equation? So up here, if you look, the numbers in blue on the screen, those are the x values that are in this set of numbers here. So the domain is 1, 3, 5, and 7. Those are the numbers that are in the domain because they're the only possible x values we see in those numbers. The y values are the range. They're what comes out of the function. So in this case, what came out are the numbers in red: 2, 4, 6, and 8. So that is the range, the solutions to the input, what you got when you put those numbers in. So otherwise known as the y values, domain and range. Okay, so here, if we said what's the domain, in this case, the domain, the values we're putting in, we're going to put in 0, we're going to put in 1, we're going to put in 5, we're going to put in 10, we're going to put in 20, and we want to see what we get out of this each time. So take your calculators right now, and on your calculator screen, you're going to type these in. You're going to go 2, and you're going to raise it to the 0 power. Anything to the 0 power, is 1. Okay? So anything to the 0 power is 1. So we're going to fill that in here. We got 1. Now, what do we get if we take 2 and raise it to the first power? 2 to the first is just 2. So we're going to fill that in. Next, 2 to the 5th power is 32. And you might be like, how can that be? That means 2 times 2 times 2 times 2 times 2. 2 times itself 5 times is 32, just to verify that that's getting us the right value. Okay, so this means we're going to take 2 to the 10th power. Every time, notice what we're doing. We're just taking this equation, 2 to the x. It's really y equals 2 to the x. And we're putting in a new value. So I'm going to take the 10, and I'm going to put 10 in here instead of x. So I'm replacing the x with a 10 and the different numbers each time. That's what we're doing each time. Okay, so 2 to the 10 and 2 to the 20. So, isn't it? Oh, this one's not on the notes. Okay, so that's okay. You don't have to copy this one down right now. This is an extra page, I guess. I don't know where the original page is. But hopefully that makes sense. Let's get to the one that is on here. This is the one that you have as your first example. So we'll do that one. Sorry, I didn't realize we weren't on the right one. So this one now says f of x equals 1.25 to the x. So we're going to raise this to each of these powers. So I'm going to go ahead and add a new calculator screen, get a fresh calculator screen on there. and we're going to raise it to the negative 3 power. 1.25, we're going to raise it to the negative 2 power. I'm going to do both of those first. The first one, when I do that, it gets me 0.512. The next one, 0.64. So I'm going to fill that in, 0.512, 0.64. If you don't have a calculator at home, you realize your computer screen can work as a calculator. You can type it in. But if you're watching this on a Chromebook, you should be able to bring up the calculator on the Chromebook as well. So then this one, 1.25 to the negative 1, 1.25 to the 0. Anything to the 0 is always 1. So we get 0.8, we get 1. Then we raise it to the first power. Anything to the first power is itself. That's also a rule. 1.25 raised to the 1 is 1.25. 1.25 to the second, 1.25 to the third. You get 1.56 and 1.95. Okay? Now, when we graph this, I always try to start with the 0 and the 1. So we're going to try to graph this. At 0, it's up 1. So I'm going to put a dot there. Try to make it a little bigger. At 1, it's at 1.25. Now what we're going to get the idea that this one is going to be increasing like one of these. It's going to kind of look like this one here. We already have that idea in the graph, so you have to kind of be prepared for that. Now, you do not have to graph all these. I'm going to graph the 3. 3 is at 1.95. Now, 1.95 is not quite at 2. So this thing's not zooming up super fast. As we go this direction, I'm going to go to negative 3, negative 1, negative 2, negative 3, and that one's about up at a half a unit. So as we graph this, here's what this one would look like. It would look like one that's zooming up kind of slowly, but that's an exponentially increasing function. Now, I didn't graph all of them. You can graph as many as you want, but I only graphed about 4 so that I would get the idea of what it looks like. Now, the domain. The domain isn't just going to be these numbers. We could have kept putting numbers in. For instance, I could put in negative 4. I could put in negative 1,000. Okay? I could keep going. I could put in positive 4. I could put in 100. I could put in 1,000,000. So the domain, what we're going to go with is the domain is all real numbers because I could go all the way to the left and all the way to the right. But the range, this graph will not go below this line, and this line would be the line of y is 0. So y has to be greater than 0 because all the y values, the line never goes below the 0 mark. It never goes underneath it. So y is always greater than 0 is our range. Okay, the next one, we have f of x equals 4 to the x. So we're going to start typing these in. I'm going to again grab a new calculator page. If you're using one of the computers here, then you can press the on button and you can use number 1, new document. You can say I'm not going to save, and then I'm going to add a calculator page. You might say, you said computer. That's correct. These are technically small computers is what they are. And they used to call calculators, all of them, they called them computers because they compute values of digits. Okay? So we have 4 raised to the negative 3 power, and we get 1 over 64. Now, 1 over 64, you may want to make it a decimal. It's going to be 0.01. I'm going to put it in both. I'm going to put this as 1 over 64, and then realize that's 0.015. It's a little tiny number. Now that 1 over 64, because the bottom number's big, it actually makes the number really small. When you divide by a bigger number, it makes it small. So the next one, 4 to the negative 2 power. is 1 over 16. Now, what's 1 over 16? We can make it a decimal. It's 0.06. So notice that's actually a bigger number. 0.06 is bigger than 0.015. But the bottom number was smaller than the last one, because when you divide by a bigger number, you get a smaller number. All right, the next one. 4 to the negative 1 gets us 1/4. Does anybody know 1/4 as a decimal? 0.25. Good. Anything to the 0. What's 4 to the 0? 1. What's 4 to the 1? Anything to the 1 is itself, so it is 4. Does anyone know 4 squared? 16. How about 4 times 4 times 4? 64. Well, good. All right, good math. All right. So now we're going to start again. We're going to graph. Everybody look, 0, 1 is a lot of times it will occur in these graphs. So 0, 1 is right here. It's 0 over 1 up. 1 over 4 up. Ooh, this one's going to zoom up faster. 2 over 16 up. You're going to be way off the graph already. Now, -3, -1, -2, -3. You're barely above the line, barely. So here's what this one looks like. This one, it doesn't cross the line, but it zooms up fast. Now the domain again is all real numbers, because I could keep putting numbers in that are extremely negative, numbers that are positive, but the range again, y is still above that 0 line, so y is greater than 0. All right, next. The range is y is greater than 0. All right, 0.5. 0.5 to the -3 gets 8. 0.5 to the -2. 0.5 to the -1. 0.5 to the 0. Anything to the 0 is 1. So 4, 2, 1. 8, 4, 2, 1. Do you recognize the pattern? Divide by what? 2. What do you think? What do you think this one is then? 0.5 or a half. If you type this one in the calculator, you get 0.25. That's half of the 0.5. Type this one in the calculator, you get 0.125. Now the domain, again, I'll tell you, spoiler alert, is still all reals. Okay? But this one's going to be a little different. At at 0, it's still at 1. We'll always try to start with that one. But at -3, it's up actually 8 squares. At +3, it's barely above the line. So hopefully those 3 are enough to see what kind this one's going to be. This one is going to zoom down and never cross the line. So again, the range is still y is greater than 0. That's the same, all 3 of these problems. It's still above that line because y is up. Y is above the line. The range is the same. Does that make some sense, everyone? Okay. Next one. Fx equals 1/3 to the x. So parenthesis 1 over 3. I'm going to put a dot on here. By putting the dot, it's going to make it a decimal if it needs to. So that one gets 27. Then it gets 9. And 3. Same as the others. It was still above 0, so its y is greater than 0. Anything to the 0 is still, now 1/3 to the 1 is 1/3. If I put the dot on, it's 0.3. Sometimes it's nice to know some of the fractions. 1/3 is 0.3. This one ends up being 1/9. It's supposed to be a 3 there. A 9th is 0.1 repeating. This is 0.3 repeating. This one's 1/27. 0.03. Really small. Now again, the domain typically is going to be all reals because I could keep putting numbers in here. At 0, I'll start with 0, 1. Now I can do a lot of these. I'm going to go to -2 and go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We get the idea. This one's going to zoom down and level off. Out at 2, it's only up 1/9. As long as you get 3, you should get the idea of how it's going to go. Usually they're going to either go like this, they're going to go like this and level off. Sometimes they go underneath the graph one way or the other. Okay, so you got to be aware that that could be the case. What's the range again? Y is greater than 0. Now, if we have one like this, the domain would be still all reals. But what's the range here? Y is less than 0 because it's below the line and they're all going negative. Okay?